All right, now we're recording. Okay, so on Tuesday, we found arc length, which gave us the length of a curve. We can use that to find the area of a surface or a surface area. So, how do you typically find the surface area of a cylinder? What's the formula we'd use? You can look it up. It's fine if you don't remember it.
2 pi h plus 2 pi r squared.
Yeah. All right. So 2 pi r h. The plus 2 pi r squared is the ends. So in this case, we're not going to worry about the top and the bottom of the shape. We're just looking at that's why it's called surface area resolution, because we're just looking at it on the outside. So we're just going to deal with the 2 pi RH. So this right here, that's my circumference. And then that's height. So when we're looking for the height of a can, it's straight. When we're looking for a height of these shapes, that's in essence my arc length. That's the curve. So that's this piece right here. So my height that's my height. So the height is whatever your arc length is going to be. So you can go through and figure that part out, that square root part, before you even do the rest of the problem, just like we were doing with the arc length formula last time. The 2 pi, right there, simple enough. The y, or f of x, that's your radius. It's going to matter depending on which direction you're rotating. If we're rotating around the x-axis, we'd want it in terms of the y equals. We'd want it in terms of the x. And my radius is going to be whatever that function is, because that's going to be the radius there. If I was rotating around the y-axis, I'd want them in terms of y. I mean, yeah, in terms of y. So solve for x equals or f of y. The rest of the formula is pretty straightforward. It's just a matter of working through the algebra to get the thing down simple enough that we can do the integration. Unlike the volume, these will always be rotated around the x-axis or the y-axis. So we don't have to worry about shifting it around other axes. Okay. All right. Everybody got the formula written down? Then let's use it. So this is the shape we're looking at. We're looking at a portion of a sphere. So my function, or f of x, or y, we used y in the formula, is the square root of 4 minus x squared. We now need to find, we also need our dy dx. We need our derivative of that. So what's the derivative of that? What's the derivative of the square root of 4 minus x squared? Yeah, so it's negative 2x. Actually, I think it's actually just 2x. The 2 is going to cancel out in a second. Yeah. I don't, so, oh yeah, because it's not, we're not bringing down it's not negative 1/2, it's positive 1/2. So yes, it is negative 2. I was thinking it was going to cancel out because I'm used to doing the integration part of it where you go the other direction. Yeah. That's why I'm like, wait, I got the negative 2 there and I have a negative 2 from or negative 1/2. Like, so yeah, you're right. So negative x over the square root of 4 minus x. What's up?
Well, I'm a little slow right now. Could you please go back over that? Just tell me how you got it.
Chain rule.
It turns into on the top.
So 4 minus x squared to the 1/2. So chain rules the negative 2 over negative 2x. And then I end up getting 1/2. And then it's to the negative 1/2 power. So that's why it's down the bottom.
Okay.
So the 2 down there is from the 1/2. All right, so we've got that. Now we're going to do 1 plus dy dx squared. So I have 1 plus x squared over 4 minus x squared. Bless you. All right, so we have 4 minus x squared plus x squared over 4 minus x squared. So I end up getting 4 over 4 minus x squared.
So you turn 1 into a 4 minus x squared over.
4 minus x squared, yep. And I still haven't done the square root part yet.
Yeah, that whole thing's still under.
Yeah, I haven't done the square root yet. So this whole thing is going to be under the square root. So that whole thing is under the square root. So that means I have 2 over the square root of 4 minus x squared. And now we can actually set up our integral. So I always pull out the 2 pi because you're going to pull that out anyway. This problem, we're looking at it from negative 1 to 1. We have r, our radius, which is y. So that's my function. My function was 4 minus x squared. Sorry, the square root of 4 minus x squared. And then times my square root. So this whole thing goes down to 2. So 2 pi 2x from negative 1 to 1. So we end up with 8 pi. That's what it really was. So as you can see, this is one of those situations we were talking about before. It's like, when do you want to stop simplifying? Like, this might have been fine for some situations, but in this case, by breaking it down to this, we were able to cancel stuff out. We didn't have to worry about it. So in this case, you want to simplify it down as far as you possibly can, because you're going to use that in something else. So. Picture for the next one. All right, let's look at this one. So we're rotating around the x-axis. Oh, because I doubled mine so I could write something before you saw it. There we go. So we've got our equation as x equals 2/3 y to the 3/2. We're looking at it between 0 and 3 on the y-axis, but we're rotating around the x-axis. So if you remember my formula, it's a to b 2 pi y square root of 1 plus dy dx squared dx. This right here, that's just my height. That's just my arc length. I could do 1 plus dx dy squared dy. Yes.
Would it be 2 pi x?
So if we're rotating around the y-axis, it would be. So that's the piece that's going to change depending on the direction you're rotating. So remember, this is basically, that's my radius, right? So that's radius. So that's telling me going from there to there, which is y in this case. If we were rotating around this direction, that would have been x. So, but since we're rotating around the x-axis, it's still y. Okay. that piece will now be in terms of y. It's still going to tell me what the length of that is. So we actually don't need to change that. That's not always going to end up being your equation. In this case, we're going to leave it as y because that's what I wanted. Okay. We have that option. Yes, you could have taken that equation and solved it for y equals if you wanted to, but you don't have to in this situation because of the way the formula works. So we're going to now do the exact same thing we just did with the other problem for the square root part. The outside is literally just going to stay as y. So my x is 2/3 y to the 3/2. I want my dx dy. So what is the derivative of this? Almost 1/2. And then I'm going to do my 1 plus dx dy squared. So it ends up being 1 plus y. So my integral is from 0 to 3. Pull out the 2 pi. Y times the square root of 1 plus y dy.
I'm sorry, how is it y to the half? Remember, I'm really bad at algebra.
So 3/2 minus 1 is 1/2.
That makes sense. Yeah.
And then you bring down the 3/2 to front, which ends up canceling out the 2/3.
Okay. Thank you.
All right. So that's my integral. How do we want to go about solving? Okay. So what's u going to be?
That's not. Am I cooked? I don't think that gives us a lot.
Let's see. What's du?
One, sorry.
Just dy. Yeah, just dy. Okay. So that replaces that and that. What about that?
Might be cooked. It was 1 plus y squared.
Yes. Yes. I can take that and solve it for y. So u minus 1 equals y. And now I can replace that y too. So you're not cooked. Just had to take one extra step. So 2 pi. You can change your intervals here. Honestly, this one's pretty easy to do, so I'm just going to change my intervals. So this is going to go from 1 to 4. This way I don't have to go back to the y's at all.
So if it's minus 1, you add 1 to both.
No, it's u equals 1 plus y. That's 0. 0 plus 1 is 1. 3 plus 1 is 4.
Okay. All right.
Because we're still using that. All right, we good up to that point? Okay. What do you want to do here?
Do we have to do integration by parts?
It might work. There's an easier way to do it though. Yeah, let's just distribute this. This way we just get basically a simple subtraction. So I've got u to the 3/2 minus u to the 1/2. Bo, that's because u to the 1 plus u to the 1/2 is u to the 3/2.
Thank you.
You're welcome.
Someday I'll learn it, but like I'm 40, so I don't think it's gonna happen.
It's okay. I just can't see your eyes at this point, so I'm just anticipating.
They're full of Robitussin.
All right. So what is the integral of that? So you add 1. So it's 2/5 u to the 5/2 minus 2/3 u to the 3/2. And we're doing it from 1 to 4. So we've got 32/64 over 5 minus 16 over 3 minus 2/5 minus 2/3.
How do you know that?
What, 64 over 5?
No, I meant like you put the back in for you and that.
Yeah, so plug 4. The 2 on the bottom is the square root of it. So what's the square root of 4? 2. 2 to the 5th power is 32. Times 2, 64.
Also simplify for like non-perfect squares where
Yeah.
it's u squared times.
Yeah. Like these are the breakdowns. Like it's the same thing with like when you're looking at multiplying by fractions. Sometimes it's easier to multiply by the top and then divide by the bottom. Sometimes it's easier to divide by the bottom than multiply by the top. It was easier to take the square root of the number first and then do the exponent up on top. Sometimes it's the other direction. So, all right. Now I'll use a calculator. I'm not doing all those fractions in my head. So 2 minus 16 over 3 minus 2 over 5 plus 2 over 3. 232 over 15. Hi. So one of the nice things, as we saw when we did this, is you don't always have to change things like we did when we did the volume. You had very specific rules about which ones you had to use. So you couldn't use this if it was Y, it had to be around the Y-axis, things like, or you do this method, the cylinder method. In this one, you're looking at the direction it's rotated and you're looking specifically at your radius and your arc length. Whatever way you figure out your arc length is fine. You can use either direction. You can use the Y's or you can use the X's to figure that part out. The only thing that you have to make sure of is if you did this and this has to match. So since we did this in terms of Y in this case, this was in Y, that had to be y and that had to be dy. So I couldn't have y here, x is here, and dx. So they all have to end up matching at the end. That's the big piece that you have to remember. All right, try this one. Oh, let me get you the picture. It's always easier when you see a picture.
So was height dy dx squared, or is height the square root of 1 plus dy dx squared?
Height is the square root of 1 plus dy dx squared. Height's basically the arc length formula.
Not pi. Square.
You're what? Oh, inside the square root?
Did something. I made it where x equals something derivative. Just kidding.
Oh, did you solve this and do it that way?
Yeah.
Okay. Then your derivative
I got
would be
2/3 y.
1 over 2. You did the integral. It's not 2, it's y. So depending on the direction you went, those would be the two derivatives. Plus 1/4y. 4y plus 1/4y. The square root of 1 plus 4x squared. So depending on the direction you went, those would be your square roots.
What's the better way to go?
This one doesn't really matter. So this one we would do the y's, which is 1 to 4. And then you'd have square root of y times the square root of 1 plus 4y, or 1/4y dy. This one, we would do the x's, which was 1 to 2. And you have x square root of 1 plus 4x squared dx.
X squared. It's not X squared.
Where? Here? No, it's just the x. Because the original, so, wait, hold on to that. Maybe it is x squared. I'm doing like two problems at once. I'm doing it two different ways at once, which is not a good thing sometimes. No, because we're rotating around the y-axis. We're rotating around the y-axis, which in this case is just the x. So it's like the last problem where we left just the y. It's just the x. All right, so the 1 plus, it's actually, finish up here, and I'm writing the rest of it down in a second. because we're rotating around the y-axis, so it's just x is the radius. We're not going to the function. All right. So this one, if you did solved it for y, so we've got the square root of y, we brought it back in, got the y plus 1/4. What they did was they changed it so they pulled out the 1/4. So this way they get a non-fraction inside the square root. When they pulled that out, that comes out to be the 1/2, because 1/2 times 1/2 is 1/4, which gets rid of that 2. So that's where that pi comes from. That's why the 2 vanished. They set u to be the 4y plus 1. So it means you have 1/4 du, which is why you have pi over 4 out in front. Square root of u. If you plug 1 into this, you get 5. If you plug 4 into this, you get 17. So that's the 5 and 17. And then they just did the integral of that, which is just 3/2 or 2/3 u to the 3/2.
Wait, how they figure the square root of y, they put it in?
Yeah, you distributed it. Well, you didn't distribute it. Since it's all under the square root, this is the square root of y times 1 plus 1 over 4y.
They just on one big square root.
Yeah, and then they distributed it. So I think in this case, I think this one worked out to be a little easier to work through. Because we have 4x squared in here, since I have an x on the outside, I could do this. If that x didn't exist on the outside, I wouldn't be able to do u substitution. Yes.
If, explain to me why the limits of
Change from 1 to 4 to 5 to 17? Or
why are they 1 to 2?
because we're looking at it in terms of the x values, which is 1 and 2. That's why we're using the 1 and 2, because those are the x values. Because everything's got to be in terms of x. So if you look at the picture, since my radius is x, right? I'm going from 1 on the x-axis to 2 on the x-axis. The other one, we're looking at the y. That's where we had the square root of y, but we're looking from 1 there to 4 there.
Wait a second.
Yeah.
Go to the next page real quick. So for
This
the,
one?
for the one where they put it all into one big square root of the y side, right?
Mm-hmm.
How come when they put it under square root, the y disappeared, they didn't distribute it in technically?
Yeah, they did. What's y times 1 is y. Y times y over 4y is 1/4. Because the y's cancel out there. So you'd end up getting, when you distributed it, you'd end up getting y plus y over 4y.
Yeah, my bad. I was about to say something like how I thought you distribute the y in, how come they did square?
Oh yeah, because there was no y there. That's why. Yes.
For my integral, I didn't leave it in u. I just brought it back to x.
That's fine.
So
You'd have plugged in the 1 and 2, or you'd have plugged in the 1 and the 2.
Yeah.
Yeah, which is fine. It doesn't change your answer. It's not even gonna actually really like cost you work or save you work really, because in this case you had to do those to get the 5 and the 17. So going back isn't that big of a deal. When we have to do like the triangles and stuff for the trig substitution, those things, that's when changing your your intervals make your life a lot easier. But in this one, it's really not saving you much time.
All right, I got one more question.
Yes.
Why side again? At pi outside of.
Yep.
the big square. How does it just go to 1 pi? Just pi.
Because I pulled out this square root of 1/4 is 1/2.
Yeah.
Times 2 pi is pi. Because remember, anytime you have a constant, you can just pull it out front. So that's what they did. And in this one, they had the pi, and they had left over from the u substitution, they had 1/4 from the 1/4 du.
So for the x side, they let u equal.
Yeah. And since I have the x on the outside, I can do, because I would turn into 4x. Oh, no, sorry, 8x. So I've got the x there and then the 1/8. And that's how I got the pi over 4 left outside. So if you notice, in essence, at this step right here, they're exactly the same.
Um,
So either one, honestly, in this case, I don't think either one's, this one you just had to do more manipulation with the square root. But the key is it can be done either way. You need to look at it as which way is easiest for you to work with what they gave you. That's the key piece. Yes.
Yeah. 2 pi times 6 minus 17 to the 3/2 minus 5 to the 3/2 over 12.
Repeat. 2 pi
5 times 6 over 12 minus 17 to the 3/2 minus 5 to the 3/2. Also, all that over 12.
That's right. I don't know where I got that.
It's
Because other than that 6/12, everything's right.
because I have this, and then I
Why do you have x minus?
is I pulled 2x out.
We pulled out 2 pi.
Or yeah, sorry, I pulled out 2 pi.
Yeah,
That leaves me with x
right. Times
minus
that.
this, and then I distributed.
You can't distribute, that's under a square root. That's all it is for.
What do you mean?
Where's that one minus coming from?
Well, this is the height and like, it's like one higher up, right?
No,
Because the limit is from 1 to 4.
right,
instead
but
of
we're
0.
rotating around the y-axis. So you're not shifting it any.
But even if it's rotated about the y-axis, it starts at 1.
Right,
So
But
like,
we're
it should
not-
be, right?
no, we don't have to shift it. Because we're not looking. Okay, so we're not taking the function from the bottom. We're looking at the function from 1 to 4. So my interval of integration is from 1 to 4. That's it. I don't have to worry about the shifting or anything else. We're not shifting this at all.
But if that's the height, then
The height is just
Yeah.
that square root, that arc length.
I thought the height is like,
No, the height is your arc length. The height isn't from an axis or anything like that. The height is just that length, which is your arc length, which is that square root of 1 plus the derivative squared.
but like it's
Rotating about the x-axis, then it would be shifted. 1 minus.
even if it was rotated about the x-axis, it still moves. It starts from x equals 1. It doesn't start from x equals 0.
That's just really where our domain would be.
Right, that's
Not our actual like problem, because x squared is supposed to be 0.
because this equation keeps going down, like it's there. We're just not worrying about this piece down
We're
here.
just measuring from this point. to this point.
Right.
Not really from 0.
Is the height not like because you have the thing that you're rotating and the height is like if you were to say that the height is the y value, that's not really true because like it's because that one that's like it's 0 because that's the floor, right?
The height, okay. So you're looking at the height as going down to something. Okay?
Yeah.
You're looking at the height as it's going down to the x-axis. It's not. The height is in the function that we're looking at, the length of that function. Wherever it happens to be. Like if I took this entire thing and shifted it up 10,
Yeah.
it wouldn't change the actual shape.
Think of the height as taking a tape measure.
Yeah.
Like-
Measuring at a point going up. It's not an absolute point.
So it's-
relative.
So is it more so distance than height?
Yeah, it's arc length. That's the distance.
Okay, but
On this one.
yeah. So I'm sitting here looking at this, I over 4, and then inside we got 2/3 u, 3/2, like square, whatever. and
Yeah.
then 5. How are we getting pi over 6?
What's 2 pi over 12? Pi over 4 times 2/3. Pi over 6.
It's like 10.
Yes.
So why is it that when we, in the first chapter class, why do we shift and why do we account for that shift? But why do we not?
Okay, we absolutely would account for the shift
Yeah.
if I was rotating around y equals 1 or y equals 10 or x equals 5. I would totally account for the shift because now I'm taking a function and I'm rotating it around something else, so my surface area would change or my volume would change. I'm not shifting this function, and we're not going to. These functions are only going to be rotated around the x-axis and the y-axis.
Did you shift the last one?
No,
The U equals 1 plus Y. and-
no, I didn't shift the I didn't shift the graph.
Yeah, you shift the graph, we shifted like the start points. So remember how it was 0 to 3?
Yeah, those aren't shifting it. That's just it's changing my interval to look at whatever variable I'm looking at that point. So you're not none of these problems. We're going to have to worry about that shift like we did with the volume. You are right though. If we did, what you did would have actually been correct, where you're rotating it around a different line, because that would change your surface area and make it either bigger or smaller depending on how you rotate it. Because like if we rotated this around that line right there, it'd be a heck of a lot smaller surface area. If we rotate around x equals 1. We're not going to do that because it makes some of these integrations impossible for you to solve because of the square root piece and everything else in there, which can make your life a lot more complicated. So these we're only going to be rotating around the x-axis or the y-axis. So no shifting. All right. We're rotating this around the x-axis.
Make sure the derivative of Y squared is 2Y.
Yes, the derivative of y squared is 2i.
Can I set it equal to x? Like y squared minus 1 equals x?
You can.
Will it make my life harder?
I don't know. I didn't try it.
All right.
For the radius. It's just, if we started with, if we made it Y equals Y squared minus 1, just be Y. Or just be X.
It would be y.
Just Y by itself?
Yeah.
Okay.
Because you're rotating around the x-axis and your radius is going up to the y. And everything's in terms of y's. If you're doing that, don't forget, they gave you the interval in x, so you have to change your interval to y.
Mr. Baker.
Yes. What's up?
So if I did it that way where I made x equal y squared minus 1,
Yep.
it would be y times my square root, right?
Yes.
Well, in that case, it ends up exactly like last problem, except with different numbers.
Okay. What was the last one? Oh yeah, this one does work out to be almost exactly. Actually, it's the exact same answer.
Yeah, that's what I was like, huh.
Because all it is just it's moved.
Would my the numbers on top and bottom of the integral stay the same? Or like how do they change?
It's not 0 and 3. You have to change them to y's. So you have to plug those values in and get the y.
Oh, okay.
So this graph, if you look at it, the whole graph, not just what I just shared with that. This right here is exactly the same curve we just did in the last problem, except instead of going this way, it's going this way. And it's shifted down so it's actually on that axis. And that's what we're looking at from 0 to 3. So literally the problem is almost identical in process to the last problem. So the book did it by setting y equal to the square root of x plus 1 instead of doing the y squared minus 1. But your answer comes out to be exactly the same as the last problem. All right, let's try this one. I'll switch back in a second. What was the what? Yeah, they did that way. So they got this was one fraction, then they distributed to the x plus 1.
Why is it x plus one? Why is it x plus one side? It's square root.
because it's y equals square root of x plus 1. So you either have to put y there, and this has to be in terms of y's, which I think is what you did.
No, I made it.
Okay. Then you need to have x there. You need to have, you can't leave the y. You have to put the y equals, which is the square root of x plus 1. So, and then they distributed that in, which gives you that fraction, which gives you that, in essence, the x plus 5/4. And then the rest of the steps were pretty much the same. All right, let's do one that's a little different. This one's rotating on the y-axis.
Are we doing another one?
Yeah,
Uh,
I can finish that one. I didn't know if you're.
yes, I tried it with x equals y squared minus 1.
Yep.
And right now I'm trying to integrate, but I got 2 pi on the outside.
Yep.
And times the integration from 1 to 2 of y squared times square root of 1 plus 4 y squared minus square root of 1 plus 4 y squared. Sorry, that's on the that's not square root. You know, that's square root.
Oh, okay. Minus.
1 plus 4 y squared. And inside the square root is a 1 plus 4 y squared. And sorry, that second term is it's also square root. Sorry, square root.
Oh.
Dy.
Well, yeah, I'm not worrying about the dy.
Yeah, I'm just working through like
I don't know how you got that. All right, let's see. So if you set y squared equal to that, right?
Yeah.
All right, so dx dy is 2y.
yeah, I did that.
Okay, so then we have, if we square that and add 1, so 1 plus that squared, square root of that, that should be just 1 plus 4y squared. Okay, so then my integral is from 1 to 2, right? 2 pi out front, y square root of 1 plus 4y squared dy. That's my integral.
Sorry, I thought the x, like, because I added x equals like function of y, I thought I put in the function of y
No,
for x.
no, because it's, so remember if we're looking at when we did this one, this was x equals. You leave the y because it's in terms of y.
The y,
You're not putting in
sorry,
x.
I have it where x equals y squared minus 1. So
Right.
like the 2 pi x, like that x is y squared minus 1.
Correct. Absolutely. But you're not putting x here. You're putting y there. If you were putting x there, you would absolutely be correct. So if you were doing the integral of a to b of 2 pi x squared root of 1 plus dy dx, you'd replace that with the square with what x was.
Okay.
So, but it's not. It's dy, so that's a y.
So replacing it with y squared minus 1, even though it's a y, that's not.
No, because that's actually x. Yes, your terms in your problem is y, but that was what x equals, not what y equals. Yes or no?
Yeah, now I get it.
Wait,
Thanks.
I'm just-
Just a quick question.
Yeah.
So anything outside of that square root should not be anything other than x or y. right?
No, like it's
Anything other than X or Y, right?
well, in this problem here, notice this at the end. That's a dx, correct? So everything in my problem's got to be in terms of x's. Notice right there, that's a y.
It goes right to the square root of X.
Because I need that in terms of the x's.
So when it's in terms of,
When we did this one, that's a dy. I don't need to change that because that was already in terms of y.
so if it's in terms of the opposite thing, that it does not equal.
Right. You don't have to
it's
change it.
always just the
Yes.
one variable.
Yes. Because if you look at the graph, the picture of this one, my radius is this, right?
Yep.
That's my radius. That radius is y equals the square root of x plus 1. So the only two things that I can plug into this, the integral, is either the y or the square root of x plus 1, because that's what gives me that length. That's what gives me the radius to that line from the x-axis. Okay, that makes sense? Or
Yeah, just like I just
I know,
the fucking
I know.
uh,
It's a little confusing.
it's clear when I make the mistake.
Yeah.
That's when it's clear. It's not clear when I'm trying to figure it out.
Right. Because you don't because it looks like it works. And then you keep going through
I
it.
mean, yeah, they're all Y's.
Yeah.
So like they all
Right.
match.
So I get the thing about when you're looking at it. So when you said x equals the y squared minus 1.
And the rule is 2 pi x times the square root of 1 plus dy dx squared.
Right. So, but
So
this,
so what I did was I swapped in the terms of integration, I swapped the dy dx to dx dy, but I should have swapped the x into a y.
because this right here is this,
Instead
is
of
that one.
turning the x into f of y.
Correct.
So f of y, not the answer, y.
Y is the answer, yes. Because what you did is you found that radius.
Okay.
Because that's what y squared minus 1 would be when x equals, because that's going to give you that length right there, not the up and down one versus what we were looking for. All right, try this one. Oh, rotating around the y-axis. That's not going to help. So my derivative was x over 2 minus 1 over 2x. It's already in terms of y. There's no way you're turning this into x, so there's only one way to do this problem. So we will do 1 plus dy over dx squared. So we get 1 plus x over x squared over 4 minus 1/4 minus 1/4 plus 1 over 4x squared, which turns into be the x squared over 4 plus 1/2 plus 1 over 4x squared. And if you remember right from the last class, I said those have a tendency to become perfect squares. And it does. It's x squared plus x over 2 plus 1 over 2x squared.
I got 1 plus x squared over 4 plus 1 over 4x squared.
You forgot to FOIL. You forgot the middle term. If you multiply x over 2 times negative 1 over 2x, you get 1/4. And you should have 2 of those.
I got x squared minus 0 plus 1 over x squared.
How'd you get 0?
X times 1 over x is, oh, that's 1.
That'd be 1. And then the 2 times the 2 gives you the 4.
I haven't done a single one of these right.
And every one of your mistakes, well, except for the y. The vast majority of mistakes are algebra mistakes. Like that one. Did you write your integral?
I mean, with the wrong.
That's fine. Did you write? When did you write for your
I got 2 pi integral of x times the square root of my wrong thing.
Okay, that's what I wanted to hear. You had x there and not something else. That's what I wanted to see. So I wanted to make sure you fixed that mistake from the last problem, which you did. So we have the square root of x squared plus 1 over 2x squared cancels itself out. So the integral is just x times x over 2 plus 1 over 2x, which actually works out really nicely. All right. Last problem. So a satellite dish is a parabolic curve. And one of the most important parts of a satellite dish is its surface area. The bigger the surface area, the more information it collects. So
You get y equals x squared.
that's what it rotated around.
What do you mean?
So to create that parabolic curve, that's the problem. We need to figure out what A is, and then we can do the problem.
He's about 1.5.
A little smaller than that, actually. All right, so we know that R has a 10-foot diameter and a maximum depth of 2 feet. So if I look at my center as being there, that's 10 feet, and that's 2 feet down. So when we're looking at our completing the square and our vertex and all that other stuff, so A ends up being, because 2C is 10, that's the width, and AC squared is 2. So AC squared, yeah, so is 2, and 2C is 10, so C is 5. So then A times 25 equals 2. So A is 2 over 25. Yes,
What does C stand for?
AX squared plus BX plus C. C is the, well, no, it's the actual, it's the diameter of the curve. 2C is going to give me the diameter. So C is the radius, the from
Oh, C
the,
is the radius.
yeah, the essence the radius. Yeah, because it's 2C is the diameter.
Why did you need to?
It's like
2c equals 10. Okay.
825 times what?
Equals 2. Because that's the depth. So in essence, I have y equals 2 over 25 x squared. Yes.
How do you know that AC squared equals 10? I'm sorry.
No, you're fine. I'm trying to think of a quick way to explain it. It's basically we're looking at the complete and the square version of the parabola, and we're looking at where the vertex line comes, basically how the vertex piece shifts down by 2. It's a formula from pre-calculus that. All right, so we have our equation. We're rotating it around the y-axis.
That means from 0 to 2.
No. 0, wait. Yes. It'd be 0 to 2, sorry. So your x is 0 to 5, and your y is 0 to 2.
Which one would you do it in terms of?
Oh, y. We're rotating around the y-axis. So
with the y.
it doesn't. You can do it with whichever one you'd like. My computer's about to die. That's the formula I would use.
Big number.
Well, it's a big satellite dish. Should be a large number.
What you would do is dx dy is what? 4 over 25x? Or minus.
That'd be 4 over 25. No, it'd be 4x over 25.
Okay. Yeah. And then you'd square it.
Yep. So you get
Get
16x over 625.
Right, so we know the squares on top of our head. Quick. Can
I know some of them. I don't know them all.
Do I say them all or no?
So then I have 1 plus that. So I have 625 plus 16x over 625.
625 is canceling it off. 16x.
No. I would be left back with 1 over 16x plus 625, which doesn't help me very much. The reason to do this is because that you can pull out.
They don't cancel?
They would cancel and get you back to that. I can't just cancel that and get down to 16x. That would make our lives way too simple. Oh, sorry, x squared. So the square root of that over the square root of that. So that's 25. So I can pull out the 25. So I have 2 pi over 25, 0 to 5, x square root of 625 plus 16x squared dx. And no, you still can't take the square root of those
How'd you get it out from underneath the 625?
because the square root, the square root, you can do the square root of the top and square root of the bottom.
Okay.
So the square root of the bottom is 25, which I pulled out.
All right.
And now for this, we have to do u substitution. So u is 625 plus 16x squared. Du is 32x dx. So 1 over 32 du equals x dx. So I can pull out the 1 over 32. I don't know 32 times 25 over the top of my head. And